all to the course Database Management System. Myself Muhammad Asifuddin Nundal, Assistant Professor, Department of CSE, Narula Institute of Technology, and this is lecture number 12 of that particular course. Today I will discuss about the concept of SQL, Structured Query Language. During my video lecture, I will discuss following topics. First, I will discuss about the history of SQL, then data definition language, domain types in SQL, create table command, and at last integrity constraint in SQL. First of all, what is SQL? SQL is basically a language, standard language in DBMS, which is used for accessing and manipulating the database. That means with the help of database language SQL, we can access the database and we can manage the database. Now, manage the database involves insertion of data in a database, deletion of data from a database, updation of data in a database. Now, SQL is developed by IBM in the laboratory, IBM San Jose Research Laboratory, and initially SQL was known as SQL language, SQL. So that means SQL initially known as SQL language, but later it is renamed as SQL and the full form is Structured Query Language. So basically it is developed by the IBM. And SQL is used to manage and manipulate database, but what kind of database model? It generally SQL is used for RDBMS, Relational Database Management System. So, and what is RDBMS? It's a kind of database model where we store the data in a relation or in tabular format. So up to that point of time, whatever the database we have already discussed in our previous lecture, all are related to RDBMS because we are storing our data or the information in a relation or in a table. So SQL basically used in RDBMS data model. And already we have discussed previously that database language may be of three types: data definition language, data manipulation language, and data control language. Now, how to use the data definition language in SQL? The thing is that data definition language in short is known as DDL. Now DDL means it's a part of database language by which we can specify the database schema. That means data definition language is a language by which we can create or we can specify the database schema or the structure of the database. And DDL allows the specification of information about a relation, means about a table, including schema of that relation, means structure of the relation, means structure of the table, the domain of value associated with attribute, then integrity constant. I will discuss integrity constant later, and also it specify the set of indices to be maintained for each relation, security authorization information for each individual relation or table, the physical storage structure of each relation on this. All this will be covered later. Now, already I have told that SQL is a kind of language. Already we have done the C language. We also know the Java language, C++ language. Like this C, C++, Java language, SQL language have also a different type of data. So it has some specific kind of data type. For example, if you consider C have several kind of data type. For example, int data type, character, float, double. Java also have int, character, float, double, and boolean. So all these data type are defined all those languages. Similarly, SQL language have his own data types. For example, char n is a kind of data type in SQL. Char n means if we define a variable of char n data type, that means that variable can store character type data, and the length of the character means the length of the string is length n. That means n specifies the at most length of that particular string. Now another data type is varchar n. Varchar n means it's a variable length character string, and again n is the maximum length of the string. Now what is the difference between char n and varchar n is that both are able to store character type string, but the difference is that in case of character n, suppose take an example, we have specified char n in place of n. Suppose we have assigned 30, so char 30 and var 30. Now suppose in char 30, suppose we want to store nit. So what happen in case of char n? Only 3 space will be occupied, 3 character will be occupied in character n, so 3 space, and each character take 1 byte. So total byte it should take 3, but as we are using character n and it is fixed length, so once we define char 30, so total length will be become 30, so 30 byte will be occupied in the memory. So whatever the length of the actual character it will be, but it is always going to take 30 byte. That means if you store only nit, only 3 byte will be used and rest 27 bytes will be wasted. But in case of varchar n means varchar 30, and if you store only nit, so varchar will only allocate 3 byte space and rest 27 space will not be used, and it will be reclaimed by the system. So it is that means the 27 bytes will not be wasted. So it is variable length character. The next data type is int. It's integer kind of value it can store. Small int is small integer. And then numeric, so it's is in the numeric int, small int, all of them are capable of storing the numeric value, but the difference is that int can take only the numeric value, those have no fractional part, but in numeric we can store value which have fractional part, and it is used in that form numeric p comma d. Here the p denotes the precision of the digit, precision of p digit, and d denotes the how many digits are there after the decimal point. For example, if we declare numeric 3, 1, that means we can store a number which has maximum length is which have maximum 3 digit number. So numeric 3, 1 means we can store a number which have maximum 3 digit, and after decimal it should have only 1 digit. For example, 44.5, that particular value, how many digits are there? 3 digit. So this 3 denotes how many digits are there in a number, and after decimal we have only 1 digit 5, so that one signifies that after decimal point we have only 1 digit. So that is a numeric p comma d can be used. Another data type is real or double precision. These are the floating point number. That means we can store a number which have fractional part, as well as we have another option for fractional number float n, where n is the number of digit. The next is create table constructs. In RDBMS, as already I have told that all the data, the information are usually stored in tabular format or in table or in relation. And in RDBMS, a database is nothing but a collection of multiple table or multiple relation. So in RDBMS, our first job is to create a table so that we can store our needed information. That means to store our needed information, first of all we have to create table or create relation. So how to create a table in SQL language? So first I will discuss the general syntax, how to create a table. For that you have to use the command in SQL create table. So create table is the command. Then R is the name of the relation or name of the table. Then parenthesis, the first bracket open. Now within first bracket open, then you have to specify all the attribute which a particular table R should have. Along with them, you have to specify the domain or the data type of the attribute. For example, A1D1. Here A1 is the name of the attribute which the relation R has, and D1 is the data type of attribute A1. Then comma, we can specify another attribute A2 and the data type is D2. Dot dot an is the nth attribute and dn is the data type of attribute n. So you can specify as many attribute as you wish. Then comma, then we can specify integrity constant 1, integrity constant 2, dot dot dot, and then bracket close. Now what is integrity constant I will discuss later in this tutorial. Before that, first take an example. This is a general syntax to create a table, but how it looks like in real life means after taking an example. Suppose I want to create a relation or a table instructor, and the instructor table should have some attribute, for example ID of the instructor, name, department name, and salary. That means instructor means who teaches. So every teacher or every instructor should have ID, name, the department name where he or she belongs, and the salary. So that structure we need to define, that schema we need to define. For that we have to use the SQL language, and we have to use the command create table. So you have to mention the create table command, then space, then you have to write down the name of the relation. Here the name of the relation is instructor, then parenthesis open, then you have to specify all the attribute of instructor. The first attribute is ID, is the attribute name, then data type. Here ID, I have defined the ID, data type as a character, and 5 specifies that ID can store a string which are maximum 5 character long. Then comma, then again we are defining the next attribute name, data type is varchar, and the length is 20, that means at most it can take 20 character long. Then department name, again varchar 20. Now here the point is that apart from varchar we have another data type like varchar is varchar2. So varchar and varchar2 are almost similar. Then comma, we have defined another attribute salary of the instructor. So salary is the attribute and the data type is numeric, 8 comma 2. Then first bracket close. So this is the SQL and if you execute the command SQL command in Oracle, then what happens? The Oracle engine will create a relation or create a table instructor with the attribute ID, name, department, and salary. So that means table will be created once we execute this SQL in our Oracle software. The next point is the integrity constraint while creating a table. Now integrity constraint means it's kind of constraint or kind of condition which we are imposing on the attribute of a particular relation. Means, as we know, the attributes of a relation has domain, means attributes store set of value. Now we can impose what kind of value and what are the value it can store by imposing the condition, by imposing the integrity constraint. And there are several kinds of integrity constraint are there. One is the not null, primary key, and foreign key. So these three are the integrity constraint. So first we will discuss not null. If a particular attribute is assigned or imposed integrity constraint not null, that means that attribute should have value. If we don't put any value, then your query SQL will not execute. It should not happen that the value that particular attribute should not have any value. So not null means that particular attribute should always have some value. For example, suppose we are creating a table instructor, create table instructor, id is the attribute, character 5, data type, name, data type varchar 20, then we are imposing a integrity constant on name attribute by specifying it not null, then comma. So not null means what happened when we try to insert some value to the table instructor, then while inserting the data into the relation instructor, always in the name field always we have to provide some value. If someone does not provide any value for the field name, then the insert operation will not be able to complete successfully. So not null means the domain of the attribute name, it should have always some value, it should not be blank. Then department name varchar 20, salary 8,2, comma, then again at the last we are adding an extra line, primary key within bracket id. So primary key is another integrity constant which we are imposing on a particular relation. Now primary key within bracket id, that means the attribute id becomes primary key. Now what is primary key? Already I have mentioned in the previous chapters. Primary key is a attribute which uniquely identifies a particular record among multiple record. That means a relation instructor have several record, multiple record. Among the multiple record, with the help of id we can uniquely identify each record, because id generally have all the employee, all the instructor have unique id, but name, you cannot be considered name as a primary key, because with the help of name you cannot uniquely identify a particular record, because two instructor or the three instructor or more than one instructor may have same name. So if you only mention name, then you may not be able to uniquely identify a particular record, but for each instructor they have unique id. So with the help of id you can uniquely identify a particular record. So here I have defined id as a primary key. So that means the id attribute is designated as a primary key. And the important property of a primary key is that it should be unique and not null. That means the domain of attribute id should be unique. Unique means the domain of id, that means all the value which are going to be stored against the attribute id, all the value should be unique. That means they should not be same, and it should be not null. Not null means the domain id should have value, it cannot be blank. So these are the property of primary key. So that means primary key is unique and not null. Suppose why I am telling that primary key is a integrity constant, because we are imposing a condition on the relation instructor. What is the condition we are imposing with the help of primary key? Is that while inserting the information in the relation instructor, while putting the value, id should not be the same for more than one instructor. Suppose in the very first time I am inserting the data, the first time that id is 1, name is Rahul, and dot dot dot. In the second time again I try to insert another record, id is 1, name is Rohit. You cannot do that. We cannot insert the second record because it's violating the constraint. What is the constraint? id should not be same, it must be unique. As I have already inserted the id 1, so you cannot insert another record which have id 1. Now take another example. Suppose we want to create a relation student which have attribute id, name, department, average marks, and we want to assign id as a primary key, means each student have unique id. So id attribute, data type varchar 5, primary key, comma, name varchar 20, not null. Why not null? Because every student should have name, so that is why we have specified not null, comma department name is varchar 2 varchar 20, comma average marks numeric 3 comma 2. 3 comma 2 means the number maximum length is 3, and then after decimal it's 2. But is it okay? I think it is not it is not right. Why? Because 3 means specifies how many digit mark should have at most, and 2 specifies after decimal how many digits should be there. So if we define that way, then what happens if we write 50.2, the 50.2, then what happens? Is it correct or wrong as per this declaration? Yes, 50.2 is okay, because 50.2, so how many digits are there? 3, and after decimal maximum how many digit? 2. So in that case 0.2 we have only 1. It's okay. Now if you consider 5.20, is it okay as per this declaration? Yes. 5.20, how many digits are there? 3. So after decimal how many digits should be there? 2. We have 5.02. So after decimal it has only 2 digits. So it's okay. Now take another example. Suppose again we want to create a relation student, but this time we want to store the name of the student, the roll number, the department name, average marks. Now the point here is that we want to store the information of students of all the department, not a single department. For example, we are going to store all the student of CSE as well as all the student of say other department EC, and assumption is that the roll number is not unique across the class, but it's unique within a class. That means roll number 1, CSE have a roll number 1 as well as EC have roll number 1, but within a single department CSE, more than one student should not share the same roll number. That means roll number is unique within the class but not across the class. So in that case, what should be the primary key? Why I am telling this? Because suppose if we assign a roll number as a primary key, then can we able to uniquely identify a particular record? No, because roll number 1, if we write roll number 1, then that particular record, that particular student may belong to CSE as well as he or she may belong to EC. So if you mention roll number 1, so it always going to identify 2 records. It is not going to identify unique record. So roll number 1 means it will identify the record from CSE student as well as from EC student. So roll number alone cannot be a primary key because it cannot able to uniquely identify a particular record. Now if we combine roll number and department name as a combination, can they be primary key? Yes. Why? Because if you mention roll number 1 and department name is CSE, then it always going to identify a single record, single student, because roll number within a particular department is unique. So that kind of primary key which have 2 attribute, that means which have more than one attribute, is known as composite primary key. Now how to define that kind of primary key in SQL? Like that, first you have to define name varchar 20, roll numeric 3,0, department name varchar 20, average marks numeric 3,2, comma, then primary key within bracket we have to mention the attributes. So roll comma department. So that means the relation student has a primary key which consists of 2 attributes. Don't misinterpret that the relation student have 2 primary key. Role is a primary key, department name is another primary key. No, it's not. Student relation or student table has only one primary key, which is the combination of role and department name. So every relation Every table has only one primary key, but the primary key may be a single attribute. If it is a single attribute, then that kind of primary key is known as simple primary key, and sometime it may seem that primary key consists of more than one attribute, then it is known as composite primary key. Here the primary key consists of more than one attribute, so this is the composite primary key. And these are the references. You may go through for more details.